Okay, so P 2.3, and this is more infrared radiation. And what you need to know now is you need to know how does this work when it comes to things like the greenhouse effect and heating up the planet and different uses of infrared radiation. So let's start off with the greenhouse effect as a recap. The sun's emitting all sorts of light towards Earth. Okay, all different wavelengths of light, it's all going towards Earth. So some is very short wavelength, some is very long wavelength. Now, and they're just the different types. The very short wavelength, for example, that would be ultraviolet, and the very long wavelength, for example, would be infrared, and this one might be red, green, blue, all of them, okay? So it's firing lots and lots of different amounts of light at the Earth. And then when it gets to the Earth, you've got something around the Earth called the atmosphere. This is not to scale because the atmosphere is only really thin. Compared to the Earth, if you had a globe and wrapped it up in cling film, the cling film would represent the atmosphere. The atmosphere is incredibly thin. It's not to scale, it's just to help you with the drawing. Now, what happens is, when it goes into the atmosphere, a lot of the UV light is blocked by something called ozone, and the other shorter wavelengths, the other longer wavelengths can go through, but not the really long ones. They're blocked by particles in the air called greenhouse gases. But what we're more interested in is, so they all come in, and the Earth absorbs them. Like we're talking about absorbers and emitters last lesson. So it absorbs the light that comes in, it then emits it back out. And when it emits it back out at a longer wavelength. So the Earth emits at a longer wavelength. So it changes, the Earth changes the wavelength of the light that lands on it. So it's quite short wavelength when it goes in and hits the Earth, but then when it's emitted, it's now a long wavelength when it's emitted. And that's important because what it means is this long wavelength is more easily absorbed by greenhouse gases. Than the short one was. Okay, so this long wavelength. So that means that what you're doing is it manages to get through the atmosphere because you've got this nice short infrared or red light or visible light coming in and hitting the Earth, and then it is being emitted by the Earth. But the wavelength that it is emitted back out at, it can't get past the greenhouse gases because the greenhouse gases will absorb them. And what they do is, let's use the example of CO2. Okay. Let's say it absorbs a wavelength of light that comes in. It makes the CO2 vibrate, which is it getting hotter, and then it will emit the light back out at a longer wavelength. Sorry, the CO2 does it at the same wavelength, or longer, the same or longer. Okay, but it's a little bit random. It can never be shorter wavelength, but it's either the same or it's longer. And that can be in any direction. It can be in absolutely any direction that's being emitted. So if you imagine that some will get emitted into space, Some will get emitted back into the atmosphere, and some will be emitted back towards Earth. But what it does mean is, it means that the more greenhouse gases you have, the more times this light is going to be absorbed, emitted, reabsorbed, emitted, reabsorbed, emitted. Okay? Each time, okay, it's completely right. So the more you have, the more greenhouse gas you have, the more likely, so it might miss and go off into space, but the more you have, the less likely it is for that to happen. So the more greenhouse gases, the less likely that the light will escape and go off into space. Okay, so that's what the greenhouse effect is. It's just more greenhouse gases means that there's more things that can absorb light and then re-emit them back towards Earth. Once they've gone into space, they're lost, and that causes the Earth to cool down. That's why Mars is so cold, because it doesn't have an atmosphere to keep the light, the energy in. Okay, you need some atmosphere to keep the heat in, otherwise you're freezing cold. But you don't want too much, because if you have too much, then you have a greenhouse effect and you get too hot. So somewhere like Venus has an incredibly powerful greenhouse effect that makes it incredibly hot.